good day, viewers. Welcome to another mathematics presentation. So in this presentation, we are going to go through the class test that was written by our physical students. So this test was based on the matrices. So let us now look at the questions. So here is our question 1. So under question 1, we have question A and B. Question A reads, given that matrix A is equal to 2, negative 1, 3, find A power T. So this one is read as find A transpose. Okay. So to find the transpose of matrix A, we are starting with our first question. So our matrix is A equal to, so we have 2, negative 1, and a 3. So to find the transpose of the matrix, the rows becomes the columns and the columns becomes the rows. Now in this case, we only have a row. This is a row matrix. So a row matrix, all the rows will become the column. Okay, so I'm going to say A transpose equal to, so here we are going to have 2, negative 1, and a 3. So this is the transpose of matrix A. We have answered our question A. We now answer our question B. So under question B, they are saying, given that A is equal to this matrix, B is equal to this matrix, find AB. So we need to find AB. AB means we are multiplying matrix A with matrix B. So what is the product of matrix A and B? So to find the product of matrix A and B, we are going to write where there is A, we'll put the matrix for A, which is 3 and a 2, times where there is B, we are putting the matrix for B, which is a 1 and a negative 2, like this. So here we are now going to say row by column. Okay, so row we have a 3, column we only have a 1. So 3 times 1. Okay, this will give us a 3. Again, row by column. So 3 times negative 2. This will give us negative 6. We are done. 2 times, again, row by column, 2 times 1 to give us a 2. Row by column, 2 times negative 2. This will give us negative 4. So this is the answer. Let us now move on to our second question. So here is our question 2. The matrix M is equal to this matrix and the matrix N is equal to this matrix. Find MT. So we are doing the same. MT means find the transpose of matrix what? M. So first of all, we need to take note of matrix M, which is 1, 5, 2, and a 7. Then here we need to find transpose of matrix M. So remember, the transpose of the matrix is whereby, so here we have this row will become a column. So we're going to have 1 and a 5. Again, we have 2 and a 7. Okay, this row as well, which also become a column, should be 2, 7. So this is how we find the transpose. So this is the transpose of matrix M. So we come to our question B. Our question B is saying find NM. So we need to find the product of N times M. So here we are going to write NM equal to, where there is N, we are going to put the matrix for N, which is 0, 1, 2, 0, times the matrix for M, which is the 1, 5, 2, 7. So NM equal to, so we need to multiply row by column. So 0 times 1, it gives us what? 1. So here it's a 1 plus 0 times 1, sorry, it gives us a 0. Row by column, 1 times 2, it's a 2. We are done. Row, column, so 0 times 5, it's 0, plus 1 times 7, it's a 7. So we come down here, row, column, so 2 times 1, it's a 2, plus 0 times 2, it's a 0. Row by column, 2 times 5, it's a 10 right here, plus 0 times 7 is 0. So your final answer now for this one, let me just write it here on top. NM equal to, so 0 plus 2, it's a 2. Here it's a 7. Then here we have a 2 as well. Here we have a 10. So this is the product of NM. This is our answer. So we have answered our question 2. Let us now move on to our third question. So this is our third question. The question reads, given that the matrix C is equal to this matrix, find C transpose. So you need to find the transpose of matrix what? Matrix C. So to find the transpose of matrix C, write C transpose equal to, so here we have this row which will be 7, 3 to become a column. Again, we have the second one where we have 1 and 4, a row to also become a column, 1, 4. Then you also have this last one where we have 2 and 5, which will be 2, 5. So this is the transpose of matrix what? C. So we come to our question B right here. They are saying express as a single matrix. So we have this matrix 1 and 8, okay, which is being multiplied with negative 0, negative 1, also 2, and the 5. So we need to express this as a single matrix. So row by column, meaning that 1 times 0 it's 0, plus 8 times 2 it's a 16, okay. Then row column, 1 times negative 1 it's a negative 1, plus row column, 8 times 5 it's a 40. So from here we are going to have 0 plus 16, this will give us 16, negative 1 plus 40, this will give us 39. So this is our answer. We have expressed this matrix and this one as a single matrix, okay. So we have answered our question 3. We now move on to our question 4. So you can see that these questions were actually simple for the class because they were just given questions that have to do with matrices because that was the topic that they learned. So here we answer our question A. Given that A is equal to this, find the transpose of matrix A. So your matrix A is this one. She's having 1, negative 3, then here a 5, we have a 2, a 1, a 0. So how do we find A transpose? So we have said the row become a column. So 1, negative 5, and the 1, negative 3, and 5, this is row to become a column like this, 1, negative 3, then a 5. Also 2, 1, and a 0 also become a row, 2, 1, 0. So this is the transpose of matrix A. So we now answer our question B. Given that P is equal to this matrix, Q is equal to this matrix, find PQ. So PQ means that we find the product of P and Q. Okay, so we need to multiply. So PQ equal to, what's the matrix for P? We have 2, negative 1, we have 3, and a 4, okay, which will be multiplied with, what's the matrix for Q, which is negative 2 and a 3. Okay, so from here we are going to have PQ equal to, so row times column, okay, row times column, again row times column. So 2 times negative 2, this will be negative 4. So row column, 2 times negative 2 to be negative 4, plus negative 1 times 3, this will be negative 3. Okay, so we are done. We can close like this. Then we come down here, row by column, 3 times negative 2, it's a negative 6. Then plus 4 times 3, it's a 12. So this will be negative 4 plus negative 3, this will give us negative 7. Then negative 6 plus 12, this will give us positive 6. So this is our product for matrix P and Q. So we now move on to the other question. Okay, so here is our next question. Given that A is equal to this matrix, B is equal to this matrix, and C is equal to this matrix, find C transpose. So without wasting much of our time to answer A, C transpose. Okay, so 2, 3, you can see this one, 2 and 3. Okay, this will become a column, 2, 3. Then we also have 1 and 0, 1, 0. So this is the transpose of matrix C. Then we come to question B. Find the x for which FB is equal to C. So they are saying we need to find the value of x of which FB is equal to C. So first thing, let us find the product of FB. Okay, so the product of FB means that you are going to multiply the matrix for A, which is 2, 3, 1, 0, times the matrix for B, which is negative 1, 0, x, and 2. So from here, we are going to get row by column, 2 times negative 1, this will give us negative 2, okay, plus 3 times x, this will give us 3x. Then row column, 2 times 0, it's 0, plus 3 times 2, it's a 6. So here we're just going to have a 6, you can cross. Then row column, negative 1 times negative 1, it's a negative 1, plus 0 times x, it will be a 0. Row by column, 1 times 0, it's a 0, plus 0 times 2 is also a 0. So here we are going to have, let's just simplify, we are going to have negative 2x, sorry, not negative 2x, we have negative 2 plus 3x. Okay, so we have negative 2 plus 3x, and then we have a 6 cross, and then here negative 1 plus 0, it's negative 1, then here we have a 0. This is FB. So now we come back to our question, which is this one. Okay, they are saying we need to find the value of x for which FB is equal to C. So where there is FB, we are going to put this matrix for FB, which is say therefore, which is negative 2 plus 3x. Then you also have a 6 here, then negative 1, 0. Okay, so this should be equal to matrix C. So what is matrix C? 7, 6, negative 1, then a 0. So now what does this mean? This means that these entries, they are equal. Okay, you can see this one, it's equal to this 6, it's the same with this one, it's equal to this 7. Even here, negative 1 equal to negative 1, 0 equal to 0. So we can just equate this negative 2x plus 3, negative 2 plus 3x, we equate it to 7. Okay, so we are going to write negative 2 plus 3x is equal to what? A 7. So from here we correct the like terms. So we are going to have 3x is equal to, so 7 plus 2. So this 2 will go where 7 is, becomes a positive. So we have 3x is equal to 7 plus 2. This gives us 9. So we divide by 3. Also divide by 3. This and this will cancel. And our final answer, let me just write it here. X 3a1, 3 into 9 is a 3. So our final answer, we can say x is equal to 3. So this was the value of x. So I hope that it's clear. You are getting something from here. So we can now move on to our next question. So here is our next question. So here we have given that we have this matrix which is 2x negative 5 1, then we have 4 and 3 is equal to 14 and negative 17. Find the value of x. So to find the value of x, first we need to find the product of this matrix and this one, then we equate to this. So we have 2, then we also have x, we have negative 5, we have a 1. Okay, so we have 4, then here we have a 3. Okay, so the product of this row by column, so 2 times 4, this gives us 8 plus x times 3, this gives us 3x. We are done there on top. Then negative 5 times 4, this gives us negative 20. plus 1 times 3, this gives us 3. So we are going to have 8. So this one we can simplify. We are just going to have 8 plus 3x. Okay, then down here we can simplify. Negative 20 plus 3, this gives us negative 17. So this is the product of the first matrix, this one and this one. Now we can equate the product to this matrix, which is equal to, so you can say therefore, so we will get 8 plus 3x, then we have negative 17 equal to, so here we have 14, then down here we have negative 17. So they are saying this matrix is equal to this one. You can see negative 17 equal to negative 17. So you just need to equate this one so that we find the value of x. So to do that, we are going to have, let me just write here on top. We are going to have 8 plus 3x is equal to 14. So this 8 will go to where 14 is. We are going to have 3x is equal to 14 minus 8. So we are going to have 3x equal to, so 14 minus 8, what are we going to get? Okay, we are going to get a 6. So we divide by 3. Even here we divide by 3. So this and this will cancel. X equal to what? 2. Because 3 into 6, it goes there 2 times. So we have answered our question 2. Okay, so we now look at the part 2, where questions from mathematics paper 2 were brought under the same topic, matrices. So this was paper 2 now, questions under the same topic, matrices. Question 12a, given that matrix Q is equal to this one, find A1, value of x, given that the determinant of matrix Q is equal to 2. So we have this matrix Q, so we need to find the value of this x, given that the determinant of this matrix Q is a 2. So we are going to assume that we are finding the determinant of this matrix. So how do you find the determinant of the matrix? You find the product of these major diagonal elements, then minus the product of the trailing diagonal elements. So we are going to say 3 times 4, it's a 12. Okay, we are answering for question A. Minus 2 times x. 2 times x is negative 2 times x. It's a negative 2x, so I'll put it in brackets. Okay, and then we equate this to 2. So here we have 12 negative negative positive 2x equal to 2. So we have 2x, okay, equal to 2 minus 12. So this 12 will go to where 2 is. So finally we are going to have 2x equal to, so 2 minus 12, this gives us a negative 10. So we need to divide by 2. When you divide by 2, this and this will cancel. X is equal to negative 5. So this is the value of x. So upon identifying the value of x, what do we need to do? Upon identifying the value of x, we need to come up with the original matrix for this one, for Q, where I'll write Q equal to, so here we have a 3, here we have a negative 2, here there was x, and our x is a negative 5, and here we have a 4. So this is the original matrix for Q. Now question 2 says find the inverse of Q. So how do you find the inverse of matrix Q? So this one, it's very simple. Okay, so we are going to find the inverse of matrix Q. We are going to say, okay, let's see how we can answer it. So we are going to say Q inverse is equal to, so this is the formula, 1 over the determinant of matrix Q times the adjoint of matrix Q. So you need to know this formula, okay? It's the one that will be, it's the one that will allow you to come up with the answer. So from here, we are going to say Q inverse equal to 1 over the determinant of Q. Have been told that it's 2 times, what is the adjoint of matrix Q? So to find the adjoint of matrix Q, this is our matrix that you have. So in terms of finding the adjoint, we just say adjoint of Q equal to. So what normally happens is that these major diagonal elements, they are just going to swap. The 4 will be here, the 3 will be here. Then we are going to add a minus sign to these trailing diagonal elements. So because this is a minus 2, it will be a plus 2, and this is a minus 5, it will be a plus 5. That's how we find the adjoint of the matrix. So this same matrix now, we are going to just substitute it there. Okay, so we are going to write, we have here, there is a 4, a 2, a 5, and a 3. So here, this 1 over 2, we multiply each and every element inside this matrix. So we are going to have 1 over 2 times 4. So we can be dividing 2 into 4, it's 2. So here we are going to have a 2. Again, 1 over 2 times 2, it will be 2 over 2, and this will give us a 1. Okay? Then 1 over 2 times 5, we are going to have 5 over a 2. Then 1 over 2 times 3, we are going to have 3 over 2. So this is the inverse of matrix what? Q. So I hope it's clear. Okay, so we can end here. Thank you so much, everybody, for having time to view this content. This has been your presenter, Mr. Mulenga. Bye-bye.